Welcome to Study Loop.
In this situation, all we know is that the radius of curvature r is equal to negative 40 centimeters, and the distance from the mirror to the image I is equal to negative 10 centimeters. So for part A, it wants us to state whether or not the mirror is concave or convex, or in other words, it wants to know what type of mirror it is. Well, since the radius of curvature is negative, that means the focal length is going to be negative. And that also means the mirror is convex. So we can say that a negative r means convex. In other words, r meaning radius, so negative radius means convex. And we can box it in as our solution for A. Part B wants us to calculate the focal length. By definition, the focal length is equal to 1/2 the radius, or r, divided by 2. So this is why it's convex, because a negative radius means negative focal length. You can tell by this equation. So the focal length is negative 20 centimeters. Part C wants us to figure out, or wants us to state what the radius of curvature is, but that was given in the question, so that's pretty simple. Radius of curvature r is equal to negative 40 centimeters. We can box it in as our solution for part C. Part D wants to know the distance to the object, so we can get that from 1 over p plus 1 over I. The image distance is equal to 1 over f, the focal length, which we now know. We can rearrange this equation to solve for p, and we find that p is equal to I times f divided by I minus f. So plugging in those values into this expression, we find that p is equal to 20 centimeters. We can box that in as our solution to part D. Part E wants to know the distance to the image, but that was given for our question. So I is just equal to negative 10 centimeters. That's all we have to say there for part E. We can box in that as our solution to E. Part F wants to know the magnification. By definition, magnification M is equal to negative I divided by P. So we find that the magnification is equal to positive 0.5. Part G wants us to state if the image that is produced is real or virtual. So to do that, we just simply have to look at the sign of the value for the distance of the image I. And since I is negative, the image is virtual. So a negative I value gives a virtual image. For part H, it wants to know if the image that is formed is upright or inverted. To answer that question, we just look at the sign for the magnification, and since M is positive, the image is non-inverted or upright. We can box it in as our solution for H. And then lastly, part I, it wants to know if the image is on the same side or the opposite side as the object that produced it. And since we're dealing with mirrors here and the image is negative, that means it's on the opposite side. So a virtual image means opposite side for mirrors. So since image is virtual, it is on the opposite side. We can box that in as our solution for part I.